So today we're going to look at continuity and behavior and limits. For today, it's just identifying a point of continuity. So number one, it says determine whether f of x equals 1 over 2x plus 1, so we're going to be given a function, is continuous at a given point, so or at a given x. So here our x is 1/2. Justify using the continuity test. So we have 3 steps that we need to do. All right, so the first one is, does f of 1/2 exist? So what we want to do is we want to substitute 1/2 in for the x. And when we do that, we get f of 1/2 equals 1 over 2 times 1/2 plus 1. Alright, so we just substitute the 1/2 into the x. Now when we do that, we have 2 times 1/2, so half of 2 is 1. We get 1 over 1 plus 1. It's a lot of 1s, so we get 1 over 2. Ta-da! So, since we got a number, yay, f of 1/2 does exist. So, tick mark. Looks good. Does the limit of f of x as x approaches 1/2 exist? That's 1/2 there. And it's because we're using this 1/2 right here. Okay. So the way we do this is we want to make a table. So we're going to do an XY table. Here's our X, here's our Y. And the book uses 6 or 7 points. We only need, 5? So I'm going to use my X that they gave us. Okay, and that was, and it also ended up being 1/2 here, but I'm not going to put that. Alright, but you can. So we're going to estimate that it's 1/2. And now we need 2 numbers that are smaller than 1/2. So one smaller than 1/2, but really close. Okay, so really close to 1/2. So it's close to 0.5. So maybe 0.4 or 0.4999999. All right. So you can do anything like that. I'm going to put 0.4. I know we're using decimals and fractions. That's okay. So, and the reason I'm using 0.4 is because it's close to 1/2, right? 1/2 is just 0.5. So let's use another number that's smaller than 0.4. Let's do 0. Actually, let's do 0.49 here, and let's do 0.4 here. Looks good. All right. And here, now the 0.5, right? So that's 0.01 spaces away from here. So let's do 0.01 spaces more. So 0.51 and we could say 6. All right. So let's check it. So what we're going to do is we're going to plug those into the calculator. We're going to do 0.4 into the x, 0.49 into the 2x into the x, and 0.51 into the x, and 0.6 into the x. All right. So let's see what to do here. Hold on. I have a solar calculator. So 1 divided by, I'm going to do 1 divided by, and then I'm going to put parentheses. This is it. And 2 times x So our x was 0.4 plus 1. Okay, so 2 times 0.4 is 0.8 plus 1, right, according to the formula. And close parentheses. I hope this is the parentheses. And equals. And get 0.55555. I'm just rounding to 0.56. And let's do the same thing, but this time with 0.49 into the x. Okay. So 1 divided by parentheses 2 times 0.49 plus 1. Close parentheses and equals, and you get 0.505. You see how it's getting smaller? Before it was 0.55555, now it's 0.505050. So it's getting smaller and smaller and closer to 0.5, because that's our y for 1/2. Ooh, it's looking good so far. So on the left side, as it's approaching 1/2 from the left, it looks like it's continuous. Okay, let's look at the right. So we're going to do the same thing. Sorry. So 1 divided by parentheses 2 times 0.51 plus 1 close parentheses equals 0.49. Okay, so 0.49, and I'm gonna make this 3 so I don't have to round. Yeah, see how that's really close to 0.5? Okay, very close to 0.5. Okay, so on to the next. Now 0.6. Let's do it. 1 divided by parentheses 2 times 0.6 plus 1 close parentheses equals, and we get 0.45. So it looks like it's going down there. But look at that. It looks like it's pretty consistent, right? Connected. 0.56, 0.51, 0.5, 0.495, 0.45. So there's no big jump in between the numbers. So it looks really good. It looks like it's continuous. Yeah. Okay. And the last one, does the limit of f of x as x approaches 1/2 equal f of 1/2? Okay, this is the last test, and for this one you do want to graph it, so I recommend desmos.com. I'm a good old friend, so I put it in already to save some time. There you go. Right, y equals 1 over 2x plus 1, and we're going to look at 1/2. So let's try zooming in there. 1/2. It's 2, this is 1, so this should be 1/2. So look at that. Yep, looks like it's connected, right? So because this worked out, because it looks like it's continuous here, right? It's nice, smooth graph, goes from bigger to smaller. You could go from smaller to bigger, just as long as it's continuous and doesn't make any jumps. Here, the graph looks like it is continuous at 1/2 as well. All right. So again, we're just focusing on 1/2, not anywhere else. Like over here, notice that it doesn't look continuous, but over at 1/2, it does. So this one is yes, yeah. That's it. So this one is continuous. Continuous.